Hello. Hello. Can you hear me? Okay, can we start the session? Reply in the chat box. If you can hear me, if you can see the screen, I will start the session. If you have any issue, please make a phone call. Otherwise, I will put the phone in the silent mode. I don't want to get disturbed. We'll go ahead. I will start the session. This is module 1, science, mathematics and engineering and technology. This is all about science, mathematics, engineering and technology, and we'll discuss what is the contribution of science, mathematics in the field of engineering, and how we are making use of technology, how this every engineering field is actually an application of science, and what is the significance of mathematics, and how the science mathematics are making use of the technology. So this is not one-way traffic, this is two-way traffic. We make use of science and mathematics. At the same instant of time, science, mathematics are also making use of the technology. So there is integration or convergence of these technologies, convergence of these fields rather. And we also discuss how engineering has evolved over the years, starting from ancient time. And the other important point is why you are given a B.Tech degree, not Bachelor of Engineering. Though you are studying Bachelor of Engineering, though you are studying engineering, why you are given Bachelor of Technology? That point also we will discuss. And what are the trends, particularly the industry trends, where it started, in what direction we are moving. Uh, uh, Whether these other branch people are competition for computer science people, how these other branch people have to modify themselves. Now remember, the computer is something like electricity, anybody can use it. Now whether you are using it or not, that's what matters. So science, mathematics and engineering and technology. So we'll start with this first PPTs, Science, Mathematics, Engineering and Technology. So Britannica defines science as the intellectual and practical activity, encompassing the systematic study of the structure and behavior of the physical and natural world through observation and experimentation. There are few things which you have to note here. One is, it is a systematic study. It is a systematic study. It is a systematic study. Science is a systematic study. It's not random. It's not haphazard. So it's a systematic study, and we study, or science, mathematics, science studies physical and natural worlds through this observation and experimentation. We observe and we experiment. So even these engineering and technology fields also study these physical and natural worlds, and make use of the solutions that are available in these worlds to solve engineering problems. So according to science, there is a reason for everything. If there is no reason, according to science, we should not believe it. But of course, there are things which are beyond the science also. There are things which are beyond the science. But as far as science is concerned, what it says is, there is a reason for everything. There is a reason for everything. Science uses systematic approach. So generally this trial and error method is not encouraged. So it's a systematic approach. Science is answering the questions through observation and experimentation. There are two things which science makes use of: observation and experimentation. So you observe. So usually observation may take place for some amount of time, or sometimes it may take years also. You have to observe over the years. They say the climatic change, etc. You have to observe over the years. You cannot just measure something, temperature is high, so the something is happening, global warming is happening. You cannot give such solutions or give such conclusions. So sometimes it is time consuming, sometimes it may take years. But anyhow, observation also is significantly contributing to the science. Experimentation is actually taking some hypothesis. Hypothesis is nothing but you can say the statement which can be true or false. You take some hypothesis, you take some problem statement, and then you prove it or disprove it. In simple terms, suppose the vehicle pollution is increasing the global warming. So that is a statement, that is a hypothesis. Is it true or false? So by experimentation you can do it. But it has one limitation. The amount of data that is gathered will have an impact on the results. So for science also, the amount of data that is available will have impact on the results. More data, maybe more accurate results. Otherwise, sometimes you may get wrong results. So as I already told you, there are cases which are not covered by the data, or which are beyond the science also. Mathematics do play a very, very important role in engineering. So we owe a lot to the Indians who taught us how to count, without which no worthwhile scientific discovery could have been made. This is the statement of Albert Einstein, who is considered to be maybe the most intelligent person ever lived on the earth. Albert Einstein. We owe a lot to the Indians who taught us how to count. So in fact, history books reveal that it is the Indians who found zero. And zero, though it is zero, it had significant contribution. It made significant contribution in the field of mathematics. So remember, in engineering, we should be able to count everything. We should be able to express it in numbers. That's what actually this Lord Kelvin said. When you can measure what you are speaking about and express it in numbers, these two are important. Measure and express it in numbers. Then you know something about it. When you cannot express it in numbers, your knowledge is of a meager and unsatisfactory kind. It may be the beginning of knowledge, but you have scarcely in your thoughts advanced to the state of science, whatever the matter may be. These are the words of Lord Kelvin. So here the gist of this statement is, as engineers, you should be able to quantify anything, express anything in numbers. Say even the beauty of a person, you should be able to express it in numbers. You should be able to measure anything. Okay, that's where these arts and say engineering differ. Arts have only description. Okay, we will say he is beautiful, he is more beautiful. Okay, like that we can say. But in engineering, we have to express anything in numbers. In engineering, we have to express everything in numbers. Mathematics has its origins in counting. In fact, mathematics started with counting. And counting is considered as an ancient skill. Okay, before the term mathematics was coined, there was counting. People used it to count. Indians, Chenna people, Egypt, Greece and Persia have actually contributed a lot to the mathematics. Remember, for all the fields, actually the contribution is from countries like India, China, Egypt, Greece and Persia, Middle East. So no contribution was made by actually Americans. No contribution was made by Europeans. Maybe small contributions at the initial stages, or at least in the ancient world. In the ancient world, civilization flourished only in these countries, and they contributed a lot. Maybe from 16th, 17th century, contributions started from these Europeans also. Contributions started from Europeans also. And, there are no contributions of Native Americans. So Native Americans maybe in 21st century, they started contributing from the 21st century. That too, if you take the America, so it's a mixed culture. People from different countries live there. That's how America developed actually. It's not because of Native Americans. It's because of people who go from here in search of opportunities to America. Indians, China people, etc. Modern mathematics can be broadly divided into two types, pure mathematics and applied mathematics. Probably as engineers, we are not interested in going into the details of pure mathematics and applied mathematics. But pure mathematics is studying the mathematics for its own sake. So it's about mathematics only, how to improve mathematics. But applied mathematics means mathematics applied to other fields, particularly says fluid mechanics. That is the research is done by both mathematics people and also this mechanical and also maybe chemical people. Okay, that is applied mathematics. So you take mathematics and apply it to some field, then it becomes applied mathematics. Engineering is derived from the Latin ingenium, meaning cleverness, and engineer, meaning to contrive, to devise. So engineering is derived from this Latin word. So remember, most of the words in engineering are derived from Latin. If you have any doubt, you can read that book, Word Power Made Easy. Word Power Made Easy. Root words. You go to the root words. If you know the meaning of the root words, many of the meanings of English words can be derived. That is one of the problems we have, because we are not native English speakers. We don't know the meanings of the terms. Don't know the meaning of the terms. I think we should first know the meaning of the different terms. Technical jargon we should know. Okay. Engineering is all about design or problem solving. Please remember, throughout engineering is all about design or problem solving. Both can be taken as same. So you have to design the solutions. You have to find solutions. You have to find solutions. You have to solve problems. You have to solve problems. So the problems can be old problems which already some people have solved. Problems can be the existing problems which people are trying to solve. Problems may come in the future also, new problems. So as engineer, you should have the ability of solving the problems. So while doing the B.Tech, you may solve some problems, but after completing your B.Tech, you cannot say that this is not taught in our class. So that's where this engineering differs. That's where this engineering differs. In school, there is a fixed syllabus. Okay, teachers will teach everything. In fact, spoon feeding will be there. Okay, spoon feeding will be there. In between the school and engineering, there is what is called as intermediate. There is what is called as intermediate. Okay, so in engineering, you cannot depend on a totally teacher. To be frank, in engineering, you cannot totally depend on the teacher. But unfortunately, this intermediate bridge is very weak. So engineering, this intermediate bridge is very weak. So here also spoon feeding. They will teach you everything and you will practice number of times, and then you go and write the exam. There will be nothing new in the exam also. All questions you might have studied already. You know all the answers already. You don't use your mind there. You don't use your mind. You just recollect everything and then reproduce. That bridge of intermediate is very weak. But if you go to the engineering, you should be able to solve problems not just under the teacher guidance, but solve problems on your own, self-learning. That's where these IITs differ from institutions like JNTU. So they stress more on what is called as self-study. They don't keep huge number of subjects. Only 5 working days, no classwork on Saturdays. Only 5 working days. Okay, so they depend more on the assignments. They give the assignments. You have to solve on your own, and you cannot copy. Though the problem may be same, but the solutions should be different. So you cannot copy. If you copy, you are gone. So self-learning, self-study, that will be more in the IITs, higher institutions. And moreover, when you solve the problems, you have to find all the alternative solutions. You should not satisfy yourself with one solution. You think about all alternative solutions and choose the best among these alternatives. And experience can be a boon or curse. We always think that experience is a boon. So definitely, in most of the cases, experience is a boon. So if you have experience, if you get similar problems, you will solve them quickly. But the issue is, what happens if the problems are new? Or what happens if the problem itself is innovative? And you require innovative thinking or creative thinking to solve it. Now, because you are experienced person, so you always think in some fashion. Okay, but because you have not encountered this innovative problem, you don't find the solution. So sometimes you may have to unlearn what you already learned and then think creatively. Think creatively. There is one person. So please go through his videos. Ken Robinson. Go through the videos. Education related person, Sir Ken Robinson. So what he says is students enter the educational institution educational institution as question mark, but they live as full stop. But they live as full stop. Anybody can give clarification for it? Anybody want to give clarification for it? You can post in the chat box. We'll discuss later, but let me first explain it. We'll discuss. Okay, we'll have some discussion at the end of each session. Students enter the educational institution as question mark, but they leave as full stop. So question mark stands for curiosity. Question mark stands for curiosity. So as a child or maybe as a student, so you are curious. You ask huge number of questions. You ask huge number of questions. Maybe you can recollect. You can recollect what you did with your parents. You have huge number of doubts, huge number of questions. You always ask the questions or elders these questions. Okay, and that curiosity should be there. But unfortunately, education system is killing the curiosity, and they are making you as a full stop. Full stop means, okay, I know everything. I know everything, and whatever I know is correct. Whatever I don't know is wrong. Whatever I don't know is ridiculous. I don't think. Already know everything, so I don't think. So full stop means learning is stopped. Learning is stopped. But the issue is for the new problems, for the innovative problems, for the complex problems, you need to think in an innovative or creative way. For that, you need to have curiosity, and you should try to solve that problem from different perspectives. But unfortunately, that creativity is killed by the educational institutions. So there is one good book which you can read, a whack on the side of the head. A whack on the side of the head. The author videos are also available in YouTube. You can watch them. But if possible, you can try to read a whack on the side of the head. What is whack? So a blow, you can say. Somebody, assume that somebody hits you on the side of the head. What happens? So you forget everything at that point of time. You remember only that one. You forget everything. You forget your family. You forget your friends. You forget your problems. Okay, you forget your success. But the only thing you remember at that point of time is that pain or what is happening at that moment of time. That is what is actually required for solving the complex problems. Solving the complex problems. Please read that book. Engineers use scientific knowledge and systematic study. In fact, every engineering field is considered as an application of science. Every engineering field is an application of science. So if you take electronics, electronics is derived from physics. You can say the computer science, you can say it is derived from mathematics and maybe electronics, physics, etc. So every engineering field is an application of science. But of course, the engineering has become a professional engineering field. So I am not saying that you have to study all the science subjects, etc. Okay. So every engineering field has grown to an extent that it should be studied on its own. Of course, you bother about the physical world and natural world, but if you just study science related subjects which are not related to you, it's of no use. So every engineering field is an application of science. And what science? That's what matters. Engineers usually use the iterative process for solving problems. Though we talk about systematic study, but we also may have to use iterative process, particularly for the new problems. So what they do is they identify the problem, build prototypes. You can say they are mini solution. Prototype is nothing but the mini solution. Take that mini solution to the customers or to the people who are suffering from that problem. Show your mini solution. Take the feedback from the customers, or from people, and then improve it. So that's where this iterative process come into picture. But all this iterative process also involve systematic study or systematic process. But at a stage or at a time, you cannot solve complex problems. But also you have to remember, you have to solve the problem as per the requirement of the customer. Engineers usually get involved in the mass production so that benefits are available to a large section of the people. So mass production. So that's where these factories, etc., come into picture. Mass production. In case of say the software industry, licenses, many licenses are given. You can make use of any software, but you should have a license for it. Whereas in the case of say mechanical engineering field, so they develop the products, and they mass produce the products using factories, so that the cost is reduced drastically, and they can be used by common man. So we also develop products. Computer science people also develop products, but our product is software. We'll study software is actually non-tangible. We'll study what does it mean. So if we take the ancient world, we can see the contributions of the church, temples, mosques, etc. Okay, they also contributed, and also these engineers have built these temples, churches, mosques, tombs, and pyramids, which current engineers are unable to understand. Some of the things current engineers are unable to understand. So you go to the temples, Hindu temples particularly. Okay, in Karnataka, there are many temples. Maybe Hampi. There are some places in Karnataka. Okay, you can see the beautiful temples. We can never understand how they created that art. So the pillars, etc., you cannot imagine. So even with current technology, so-called current technology, with computers, with internet, etc., now current generation of engineers are unable to construct such temples. They cannot. Okay. Even Ramanujam statue, which is recently inaugurated. Okay. That is nothing but multiple parts, they are joined together. They are created in somewhere in China, and they brought, and then they joined together. But if you take the temples, they have not joined it. Single pillar. You can see on single pillar they are constructed. Now how? Nobody knows. And also there is mention of these engineering related contributions in Mayasabha. In Mahabharata, there is mention of this Mayasabha, okay, which happened in so-called Dwapara Yugam, Satya Yugam, Treta Yugam, Dwapara Yugam, Kali Yugam. Satya Yugam, Treta Yugam, Dwapara Yugam, Kali Yugam. So Mayasabha, how they constructed that Mayasabha, it's a wonder. Mayudu is, we can consider him as one of the first engineers, Mayudu. So that creation, that that building is named after the person called as Mayudu. That's why it is called as Mayasabha. Modern engineers are able to understand some of the contributions of the ancient world. Somewhere you can see the pillar which is hanging. Nobody knows how they created it. So the title engineer, however, was not created until the Middle Ages. So only from the Middle Ages we started using the term engineering or engineer. So a new idea comes suddenly and in a rather intuitive way. These are the words of Albert Einstein. So that means you may be having a complex problem, you struggle for years to solve it, but suddenly you get the solution for it. Intuitive way. Intuition means sahaja gnanam. Intuitive way. Suddenly you get the solution. But you have to note that, but intuition is nothing but the outcome of the earlier intellectual experience. You thought about the problem and the different ways of solving the problem over a period of time, and because of it you got the solution. It's not about the magic. That's why if you have a complex problem, think about the problem and go to sleep thinking about the problem. On one fine day, in the dream you get the solution. Wake up and write the solution. Don't wait for the morning. If you wait for the morning, it's gone. Okay, that's where your the subconscious part of the mind starts finding the solutions. So your conscious mind usually finds solutions to only routine problems. The subconscious mind should come into picture. So again, these are the two good books. This is not the name of the book, but this is the Law of Attraction. The name of the book is The Secret. You can search for the videos also in YouTube. Law of Attraction and the Power of Subconscious Mind. This is one book. So if you have time, try to make some time and read these things. The Secret and the Power of Subconscious Mind. So don't think negatively. There is a lot of power with the positive thinking. So subconscious mind can find solutions to many things. So we studied about science, we studied about mathematics, we studied about engineering. Now technology. Wikipedia defines technology as the science of craft, which is some of the techniques, skills, methods and processes used in the production of goods or services or the accomplishment of the objectives. The science of the craft is involved. So you make use of all techniques, skills, methods and processes which you know. Okay, technology, the significant advantage of technology is technology empowers the common man, gives power to the common man. Okay, it doesn't matter whether you are a highly intellectual person or you don't know anything, you are illiterate, nishani, but still technology empowers the common man. Okay, it doesn't matter. Now illiterate can make a phone call to the USA. The highly intellectual person, let's say like Einstein, can make a phone call. So technology doesn't differentiate between a common man and an intellectual person. It is available for everybody. Technology empowers the common man. Any person can use the technology without knowing anything about the technology. You are making use of the cell phone. Do you know how it works? How it is designed? No. So any person can make use of the technology. And one mistake is we always think that technology is about electronic goods. No, technology is not about electronic goods. So before the invention of the, or before this electronics etc. came into picture, electronic field came into picture, technology existed. Wheels, telephones, computers and internet are all technological developments. Okay. Technology is double-ended sword. So anything that is powerful has two sides of it, has two sides for it. So it has both advantages and disadvantages. You can use the technology for the benefit of the mankind, you can destroy it. Now atom bomb is there, okay, nuclear technology. So in many countries, nuclear power, they don't have power cut because they depend on the nuclear power. So they can generate the power. At the same instant of time, he can drop a nuclear bomb. Maybe he can destroy the entire world. Maybe if Third World War comes and people make use of these nuclear bombs, then they are capable of destroying the entire world. Entire world. Nothing will be there. So enjoy life. Enjoy life. Plan for the future, but at the same time, try to enjoy every moment of time. So whether we accept or not, technology is driving us. Actually, we should drive the technology, but the reverse is happening. Technology is driving us because everybody has nowadays smartphone. Do you really need the smartphone? Suppose if I have a computer, let us assume that you have a computer. Do you really need a smartphone? So in most of the cases, in most of the time, you don't need. But nowadays, it's a symbol of prestige. Everybody wants a smartphone. Everybody wants a smartphone which has good features. 90% of the features we don't make use of, but still, it's a prestige question. So everybody wants to have it. So in the modern world, technology is not just used for development of tools, but various purposes, including computing and communication. So technology is so integrated with our daily life that we don't recognize it as something different. So we don't recognize that smartphone is a technology contribution, is a big contribution of a technology, big contribution of technology. Another one is internet, but we don't recognize it as a separate thing. Okay, for us, maybe for the generation, for our generation, internet and smartphone are really very good technological developments. But maybe for you, because you are born with the technology, so you don't recognize the importance of the technology. And the technology tools need not be machine made. Technology tools need not be machine made. They may be made with the stone, human made, maybe made with the stone, maybe made with the wood. So there are many such technological contributions in the ancient world. The hunting, the devices that are used, the devices that are used for hunting animals. Okay, they are nothing but the contribution of technology. Though the term technology didn't exist at that point of time, but still it is a contribution. Your clothing, etc. There are also technological contributions. There are also technological contributions. So that is regarding the science, mathematics, engineering, and technology. So all are interlinked. All are interlinked. That is what we are going to study in the next session. But engineering doesn't exist without science and mathematics. So even in the field of science and mathematics, nowadays engineering is being used. Technology is also used. Technology is also contributing a lot to the development of science and mathematics, even mathematics. All the fields, in fact, all the fields, arts, medicine, etc. all are interlinked. One is depending on another. How they are integrated, we are going to study in the next session. So these are some of the references. Some of the references. Remember, these references are for the entire module. For the entire module. Shubhodayam. Good morning to all of you. So we'll stop this session. You can give some kind of feedback. I will go to the next session maybe in 3 to 5 minutes time. Please reply in the chat box. See, probably if you are watching in the mobile, then you have to adjust your brightness, etc. for screen clarity. So please reply in the chat box. Any issues? Any issues? Any issues? So I can see only 13 concurrent users. What happened to others? That's why I asked, are you interested or not? If you are not interested, don't reply, please. Yeah, I'm not doing it for my own sake. Of course, I have my own targets. I'm at the stage of experimentation. Why am I experimenting? Means I want to reach I want to become a global teacher, not just this one. This is just experimenting. I'm learning new things. What videos people are watching, how much time they are watching. We're all collecting analytics so that they can be improved. This is only the first version. There will be revisions. There will be videos on different subjects. We'll definitely totally modify the course also in future. Any issues? If you want to ask anything, so if CR is there, ask others to join, please. If you are if people who are watching are belong to only computer science or JNTU, ask your student to ask your CR to send a message to everybody. Otherwise, let them have clarity. If they are not interested, it's okay, fine. I'm not bothered about the numbers. Either join or exit from the group. That's what they have to do. Please. Okay, 2 minutes time. Now it is 10:50 exactly. So 10:53 will start again. Meanwhile, if you have any doubts, you can please put them in the chat box. Who is your CR? Reply. So if you are CR, please ask your friends why they are not joining. Let them exit the group. Okay. Let them exit the group if they don't want to join. If they're not interested, it's okay. So because from the next week onwards, I will conduct 2 sessions. I mean, 2 modules will be covered every week. Did you inform Habib? Is it Habib? Just put a message in our WhatsApp group. Inform who wants to join, who wants to exit. Will remove forcefully. Okay, shall I start the next session? So next is integration of science, mathematics, engineering and technology. Okay, in the last session we discussed that science, mathematics, engineering and technology are different fields of study, but of course they are related. They are related, but we studied what is science, we studied what is mathematics, we studied what is engineering and what is technology. Now how these are integrated. If they are independent fields, probably we don't bother too much, but they are integrated. Science doesn't exist nowadays without engineering also, or technology. So every engineering field is an application of science. Every engineer has to quantify, express everything in numbers. For that, mathematics is definitely required. And technology is driven by the laws of nature, physical laws, natural laws, and also concepts of engineering are used in the development of technology. So science, mathematics, engineering and technology are all interrelated. Each one is contributing to the betterment of the other. Science is basically asking questions. Science is basically asking questions. That curiosity is required. Ask questions, and then so as you start asking questions, you try to find the solutions and you will get the solutions. Once you stop asking questions, you don't find any solutions. Technology enable more deeper questions to be asked and also find better solutions in an easy manner, maybe in a quick manner also. Quick manner. So there will be number of questions. For some questions, you may try to find the solutions. For some questions, you may think that they are impossible. Okay, solutions are impossible. But technology is enabling us to ask deeper questions, and also technology is enabling us to find deeper solutions, to find better solutions. Engineers are also making use of technology. Okay, engineers are also making use of technology to devise solutions to problems. So basically, the contribution of technology is it makes things easy. It makes things easy. So we can do things in a quick time. Science and engineering have a parent-child relationship. So every engineering field is an application of science. Knowledge of all fields like arts, medicine, etc. is used in engineering. So we study the different things, and the nature provides some solutions. We try to make use of the solutions that are provided by the nature in solving engineering problems. I'll just tell you one example. So if we observe ants, so ants always move towards the food item. If you place any food item, if you observe after some amount of time, all the ants follow the same path and they will move towards the food item. How do they find it? That is called as ants foraging. How do they find it? So what the ants do is they use one chemical called as pheromone. So as they move along, they leave a chemical. So ants follow the path of chemical, or path of heavy concentration of that chemical. So because after some time, some of the ants move only in that path, so the pheromone level increases, and all the remaining ants also will follow the same path. Now, how do you make use of it to find the solutions to the engineering problems? So we make use of solutions. We are not getting into the solutions, but we make use of solutions provided by the nature. Solutions provided by the nature will be used in engineering field also. So the knowledge of science helps the engineers in understanding the constraints. Now, what you can do, what you cannot do. What are the constraints? But there is one field called as computer science field, which deals with non-tangible objects and which allows you to go beyond the constraints. That's where the computer science is different. All the remaining fields deal with what is called as tangible objects. Tangible means you can say which we can touch, which have some physical form which you can touch. But computer science deals with non-tangible objects. Computer science deals with software. Can you touch the software? No, you cannot touch the software and see it. It may be there in the form of CD. Okay. But CD is some other device, it's not the software. Software is present inside the CD. But can you touch the software? No. So software is a non-tangible object. But remember, it is the non-tangible objects that control tangible objects. It is the non-tangible objects that control the tangible objects. So air is a non-tangible object. Can you touch it? You can just feel it. But can you touch it? No. But without air, we cannot live. Similarly, in more philosophical terms, if you believe in God, God is non-tangible. Can you touch the God? No. Can you see the God? No. But we believe that it is the God who controls everything. So the software or computer science field is controlling all other engineering fields. Not that it is, computer science is the greatest field. It's not like that. Okay. It happened with other fields also. Before electricity, all the devices are controlled manually. But with electricity, they are being controlled with electricity. They are provided electric power. Okay, similarly, nowadays, in the age of computers now at present, so computers are being used to control. So, for example, the virtual reality field allows you to go beyond the constraints. Using virtual reality field, you can create things which you imagine. So, remember, this virtual reality field has a number of applications, including medical applications like treating phobias. Now, if somebody has fear complex, if you want to go into a lift, they fear. Some people have those problems. Now that problem can be solved using virtual reality. And moreover, say suppose some people unfortunately lose their younger ones. Maybe their children die because of some disease or some accident. So it's difficult to bear such things. Now, in what way this virtual reality field can contribute is, using virtual reality, probably you can create the images, you can create the videos of the persons who no longer exist. You can create, and you can create a sense of touching also. You can go and touch it. Okay, by using what is called as haptic feedback, you can touch it. So these are the fields which are moving, which are going to drive the future world. Virtual reality, artificial intelligence and machine learning, data science, Internet of Things. They are going to rule the maybe next 10 years, 20 years, 30 years. Okay. So it is believed that your smartphone will vanish in another 10 years. Another 10 years. Probably don't go and watch the things in the theaters. 3D movies we can't usually watch, and even if you go and watch 3D movies in theaters, the experience is bad. It's not good. So by using virtual reality field, probably we can do it. So and also remember that all these are interdisciplinary fields. AI is used in virtual reality field. Virtual reality is used in AI. Data science is based on AI and machine learning. They're all interrelated. They are all interrelated only. So in summary, science and mathematics can be considered as tools in engineering. We make use of them. They can be considered as tools. Whenever there are tools, things are easy. If you don't have tools, things become difficult. Suppose if you take a knife, if you want to cut vegetables, if you have knife, you can cut them easily. If you don't have knife, how do you cut them? It becomes very difficult task. So science and mathematics can be considered as tools in engineering. Now the one important point, why you are given B.Tech degree, or in fact if you consider JNTU, it is Jawaharlal Nehru Technological University. So we are concentrating more on the technology. We are concentrating more on the technology. So why you are given Bachelor of Technology? Though if somebody asks you what you are studying, you will answer engineering. But then in that case, why you are not given Bachelor of Engineering? Why you are given Bachelor of Technology? So for this, we have to consider these ABET definitions: Accreditation Board of Engineering and Technology, a worldwide organization. Accreditation Board of Engineering and Technology. In India, we have this NBA, National Board of Accreditation. Probably all of you know, recently this NBA visited our campus also. So this Accreditation Board of Engineering and Technology defines engineering as the profession in which knowledge of the mathematical and natural sciences gained by study, experience and practice is applied with judgment to develop ways to utilize economically the materials and forces of nature for the benefit of the mankind. So profession in which you make use of knowledge of mathematics and natural sciences. knowledge of mathematics and natural sciences, gained by study, and experience and practice. They also contribute experience and practice. So as you go on, use the principles of mathematics and natural science, you come to know how to solve the problems in a better way. Experience do contributes and practice also do contributes. It's not just about study. As a student, you are studying, but after completing, you experience, you practice. In fact, you also practice now, but you get huge practice, real-time practice when you complete your degree. So what you do, you practice and you develop ways to utilize economically the materials and forces of nature. Economically, given the resources, you should always use the resources in an efficient manner. Minimum resources are to be used. Okay, don't try to make use of all the resources. If you make use of all the resources, maybe there will be no future. And always use it for the benefit of the mankind, not for the destruction. That point should be there. That point should be remembered. That's why you study this professional ethics. I hope this is part of your curriculum. Maybe in first sem or second sem it will study for the benefit of the mankind. That is engineering. Okay, that is engineering. That is engineering. If you consider engineering and technology as the part of the technological field that requires the application of scientific and engineering knowledge and methods combined with technical skills. Similarly, engineering technology also makes use of knowledge of mathematics and natural sciences. No issues. But it combines the technical skills. So these technical skills are added in support of engineering activities. It lies in the occupational spectrum between craftsman and the engineer, and at the end of the spectrum, closest to the engineer. So if we can draw a line, so at this point you have what is called as craftsman, and next comes, say at this point of time, next comes technician, next comes technologist or technocrat, next comes engineer, So you are somewhere here, just a minute. You are somewhere here. That's why you are given technology degree, not engineering degree. So technical skills are considered as more important. Okay, skills are considered as more important. That's why you have this what are called as workshop, IT workshop, etc. And even the government of AP is putting a lot of efforts in creating what is called as skill university. Because skills are required for the survival of the man, for the survival of engineers. If you consider the jobs, only few jobs exist for engineers, but many jobs exist for technocrats or technologists. So everybody should have these skills. That's why you have what is called as ITIs, polytechnics and engineering colleges. ITIs, polytechnics. So maybe craftsmen, so they know only one skill, they will do only one skill. Craftsman, చేనేత మగ్గం నేసే వాళ్ళంతా they come under craftsman. They know only that thing. They cannot do other things. That is the reason why many of them commit suicide whenever they don't get support from the society. Technicians, maybe polytechnics, etc., prepare technicians, and they may come between this technician and technocrat. And you are here. So you learn not only engineering but also technical skills, but you learn more of the technical skills. You make use of the technology, and also you find new technology. That's why you are called as, or you are given the Bachelor of Technology degree. So in good old days, students were given the Bachelor of Engineering degree, but nowadays you are given the Bachelor of Technology. The reason we discussed. And engineering is supposed to solve new problems, but engineering is become more application oriented. Many of the engineering fields are becoming more application oriented, because see, if you consider these problems, so in most of the cases we have to solve routine problems, or problems which can be solved easily. Now and then you get complex problems. You have to solve complex problems. For routine things, you require routine knowledge. Your engineering provides that routine knowledge. So application oriented. For different applications, you make use of your engineering knowledge. Students are expected to be technologists and engineers. Students should have skills and should use technology. So computer science deals with non-tangible objects. Computer science has its applications across all the fields of engineering and also arts and science, including medicine. Now, if you take medicine, orthopedist, if you have any problem with your hand, if the bone is broken, and if doctor feels that the bone cannot be set right on its own, then what he does? He inserts a rod inside your hand. Instead of bone, you have a rod and screws are fitted. What is that rod? What are those screws? That is nothing but engineering. So some of the fields of medicine are riding on the back of engineers, They are depending more on engineering. Though we may not realize it, they are depending. Laser treatment for your eyes. What is that laser treatment? Is it medicine? No, it's actually engineering. So the beauty here is, whenever there are technological contributions, anyone can make use of it. If a common man can make use of it, why not doctor? Anyone can make use of it. But you need to have some knowledge of how to make use of it. How much, what should be the intensity of the laser beam, and up to what time it has to be projected onto the eyes. That knowledge should be there. Probably engineers will not be having there, but medical people will have that knowledge. So this medical field is making use of engineering. And there is one beautiful code complete. This is one of the good books. If you have time, please read this book, Code Complete. Computer science has some of the most colorful language of any field. In what other field can you walk into a sterile room, carefully controlled at 68 degrees Fahrenheit, and find viruses, Trojan horses, worms, bugs, bombs, crashes, flames, twisted sex changers, and fatal errors? So here the thing is, you in the computer science, the computer lab should be free of dust, bacteria, viruses, etc. So we have what is called a sterile room, and because computers generate lot of heat, the temperature has to be controlled. The ACs, air conditioner should be there. You go there and you actually find viruses, not the viruses, natural biological viruses, but search viruses, Trojan horses, worms, bugs, etc. in your computer. You search for them. If there are any there, you have to remove them. Even there are what are called as logical bombs, etc. Logical bomb. Okay, when a logical condition is met, something happens. So you search for all those things, and also errors in the programs. Mathematics, science, engineering, and other fields contributed to the development of a computer. Vacuum tubes, transistors, etc. can be considered as the contribution of physics or electronics, which is the application of physics. Okay, so computer science field, for the computer science field, there are many contributions. So if you consider the transistors, transistor is one of the main component of the CPU. Okay, transistor is the main component of the CPU. Who contributed it? It is the physics. Okay, William Shockley, Robert Noyce. So physics is nothing but the physics. Initially it is physics. Now electronics is derived from the physics. So the field of physics, field of electronics contributed to the computer industry. And also the printed circuit board or the integrated circuits. They are the contribution of metallurgy. They are not the contributions of electronics. They are the contributions of metallurgy. In fact, electronics people are again riding on the back of the metallurgy. So all the chips, etc. are made by metallurgy people only. The logic of programming, logic of solving problems is derived from mathematics. So mathematics is also contributing to computer science. The battery, etc. can be considered as contribution of chemistry or electrical engineering field. Battery. The concept of algorithm can be assumed to be contributed by mathematics people only. So all the fields, whether they are other engineering fields or non-engineering fields, they are contributing to the computer science. Similarly, computer science is also contributing for the development of other fields. So initially computers were used for only mathematical operations. At later stages, people started using them for other operations also. That means initially only numbers were manipulated, but strings, etc. are also manipulated nowadays. In fact, we concentrate more on the strings. So domain knowledge is important. So computers nowadays, anybody can make use of it, but the domain knowledge is important. Computer science is no more just about computers. Okay, previously it was just about study of computers. Computer science is no longer about just computers. Computer is just a tool nowadays. Computer is just a tool which can be used to solve problems. A separate thinking is developed recently. Somebody coined this term, what is called as computational thinking. You can say thinking like a computer, basically. Computational thinking is required. So that is regarding this integration. So all the fields are related. Okay. So don't assume that computer science is great or electronics is great or civil is great or etc. But what we have to realize is all are depending on other fields. Nowadays, even this, remember this civil will be very much influenced by computer science or contributions in the field of computer science. Probably you might have heard about this one. There is one temple, Shivakoti temple. Besides this Sharda Nagar, Shivakoti temple. So that temple is being moved. The pillars itself are being moved. Okay. So what we assumed is everything has to be destructed and then reconstructed. But no. Nowadays we are able to move the buildings. So all the fields have their own significance, but they should become computer oriented. If they don't become computer oriented, then they cannot survive. Unfortunately, people are not thinking in that direction, at least in India. We'll discuss that one also. Shubhamastu. Thank you. This is the end of this session, integration of science, mathematics, engineering and technology. Take a break again for 3 minutes. Come back for the next session. Any doubts you can ask. Any doubts? So you should know the interdependency. You should know the interdependency between different fields. Probably now we want to know uh, what is required for you immediately, but as you go and live, as you go and do the jobs, you realize the importance of other fields also. You should have a broad knowledge. Any doubts? Otherwise, take a break. Shall I start the next session or stop for now? Stop for today. Reply in the chat box. Reply in the chat box. Bhargavi, Nikesh, Pawan Kalyan, Santan Reddy, Habib, Dinesh, Raju, Vignesh, Chandrika, Avineshwar. Shall we continue or stop for today? Please reply immediately.